Okay, so the next portion of this lecture is going to be unit testing and debugging. Can anyone tell me what unit testing is? Unit testing? Okay. What's a unit?
Like a certain part,
Mm-hmm.
a larger,
Yeah.
thing.
It's like a self-contained part of something that's bigger, right? Like for example, if you have a car, one unit might be the engine, right? Another unit might be the steering control. One unit might be the I don't know. Suspension. Okay, and the idea is this. Okay, with unit testing is this: is every is if okay let me is if every unit within the larger system is working, then what does that tell us about the system? The system will work. Okay, if every component of a car is functional and correctly working, then the entire system should be working. Okay, so we're going to learn how to create unit tests so that we can test portions or units of our program. Okay, and if everything is to pass, that means that our entire program is correct, or there's no bugs in our program yet. Okay, so this goes underneath debugging, right? Okay. Pseudocode. Let's talk about pseudocode. What is pseudocode? Pseudocode is writing out the logic of what you're trying to do before you actually code it. Okay, so when you write pseudocode, let me show you. It might something along the lines of this. Okay, so let's say we have a divide. Maybe not this one. Let's maybe go into the control flow practice that we did. Okay, and let's maybe look into this calculate cost. Okay. Pseudocode is written in plain English. Okay, you don't write actual code, but usually you want to write it in the same structure that you would for code. Okay, so for example, you might have a comment here that says, if distance is from 50 to 100, then you would say something like, notice how I kept the structure the same for an if I use that indent, right? Then print 100, okay? And then if distance is from 25 to 50, then print 10 if or else print 0. Okay, so it's pretty much like writing code in plain English, right? So that's very easy when I want to code this portion, right? It's very easy just to convert this line to code, convert this line to code, convert this line to code. So pseudocode is basically writing out your program in a very easy and in English, okay, not in code. Use natural language, okay. Don't worry about the details. Worry about the structure and the logic. That's what pseudocode is for, okay. So don't worry about the syntax or whatever. Just get the logic down on the paper so that you know what goes where and how it needs to be structured. Does that make sense? So pseudocode, that is pseudocode, okay? Yeah, so for example, for all the elements in this list, increment the value by 1, print the new value. Now, how do you code it? That should be the next question, right? So pseudocode is like a setup for, getting the logic down before you start coding, okay? And then you can obviously convert this to code, right? You can convert this statement to code using a for loop, right? For int I equals 0 to I is less than word dot length, I plus plus. Okay? You can convert that easily, okay? So let's practice making some pseudocode. We can skip this portion for now. All I need you guys to know is that you can do it like this, write comments or write it down on a piece of paper, to be honest, a lot of times, because when you have an algorithm that's maybe like 100 lines long or 50 lines long, it's not as easy to just go ahead and start coding it immediately. You might need to write some pseudocode first to write down your logic, because you don't want to start writing 25 lines in and realize, oh shit, my logic's flawed, but you just wasted time writing 25 lines. Okay? So pseudocode is important. If it's pretty simple to the point where like you think you can just code it right away, yeah, you don't need to use pseudocode. But I would definitely suggest for more complicated ones, you will be using pseudocode. Trust me. Okay. Let's talk about edge cases. Edge cases are a very core concept when it comes to debugging, because an edge cases are essentially cases that you might not have considered. Okay, so an edge case is usually some sort of like, like maybe like for example, let's look at this algorithm here, the one where we print the distances. Can you guys think of some examples of an edge case for this algorithm, for this function? Yeah, what if I give the distance equal to 10,000? Are you handling that scenario, right? What if I give you negative 20? Are you handling that scenario? Those are examples of edge cases. Edge cases that aren't really normal, but they're like, they may make or break your code, right? A critical point is similar to an edge case, right? A critical point might be something like the number 50, right? It's the teetering point, right? Because sometimes, like, depending on the implementation of this, if I just changed it like this, now if I give the distance 50, it's going to return 50, right? Because I changed that equal sign, right? So now it's getting caught in this range instead of this range now, right? That's an example of a critical point. So when you're debugging, you have to consider, have I handled all the critical points? Okay? A common issue or a common thing that beginners do is they'll do this. What's going to happen if I put the number 50 in there? What is it going to return? It's going to return 0, which is not what we want. Okay? So that is a very big consideration when it comes to debugging. You have to ask yourself, have I handled all the edge cases? Have I handled all the critical points? Okay, there's only a couple critical points here. It'd be like 50, 100, 25, and 0, right? So handle your edge cases or your critical points, okay? There you go. Meaning have an implementation, the correct implementation for the critical points, okay? Now, the critical points here for this implementation highly depend on the description of the function that I gave, right? In the homework assignment, I said that if the distance is equal to 50, which means it includes 50, then it should return 100. So that tells me that I should put the equal sign here. If I put it here, that would be wrong, right? So again, that's critical points, okay? So imagine you're looping through a list and dividing everything by 2. What's an edge case for this scenario? You're dividing everything by 2. 0 divided by 2. Okay, that might just give you 0. It's fine. Yeah, what if it's like 3? What if it's an odd number, right? Maybe if we're doing integer division, right? What's 3 divided by 2 when we're dividing 2 ints? You guys know? We'd actually just put 1. Because if it was 1.5, that'd be a double. But we're doing integer division, right?
Yeah.
So 3 divided by 2 would actually just return the number integer 1. So that's a common pitfall of using integer division, okay? It doesn't really account for remainders, okay? That's why we usually use doubles when it comes to division, okay? Does that make sense? But what if, I don't know, what if the list is empty, right? There's no list. Or, you know, did you handle that scenario? Or maybe, you know, the list has types int, and you're dividing by 2.0, or I don't know. There's a lot of cases, right? I'm not exactly sure why I chose that one. Okay, but critical points, right? You always have to identify what the critical point is in your function, okay? A lot of like math functions always have critical points, okay? If I were to take the substring of hello, what would be the critical points? So if I wanted to get hello, right? Let's say I just wanted the ELLO, right? That would be what? From 1? Would the answer be 1 to 5 or 1 to 4? So it'd be 0, 1, 2, 3, 4, 5, right? What would happen if I did something like that? Yeah, I might give you something in some sort of error saying that, hey, you don't have an index at position 5, right? It might throw an error, right? So the critical point when it comes to strings and indexes are always the boundaries of the index. Okay, meaning it starts at 0 and we know it ends at 5, right? But a lot of the times we'll have issues where we'll take the substring, like people will do this, and they'll only end up with ELL. And they're like, wait, what the heck? I put 1 to 4 though, right? That's a critical point, right? The last index is the critical point, right? So if you actually knew how to use the substring, you would know that this 5 is not inclusive. This second parameter is not inclusive. So we need to use this 5 to include the fourth index, right? So the beginning and the end is tricky for indexing, or when it comes to the string indexes, right? So that's what we call the critical points, right? Oops. Okay, so edge cases, okay? Always keep that in mind, because edge cases are the ones that are going to break your case always, okay? I'll give you an example. In my Amazon interview, my phone interview when I was doing Amazon interview, he gave me an algorithm to write, and I completed it in like 15 minutes. And he was like, okay, that looks good, but you didn't handle this one edge case. And I was looking at it, and he was right. I didn't handle the edge case. But that edge case made me have to rewrite my entire code. So I had to delete the entire thing and rewrite a completely new algorithm just because of that one edge case. Okay? So definitely keep that in mind when you're right. So kind of when you come to a problem, kind of compile in your head what certain edge cases might be. Okay. Some common ones are, think of when something's empty, or think of when something is null, or when something is 0. What happens then? Okay. So for example, like if I want to do the division divide by, right? Let's say I have a function called divide. Remember, we talked about divide, this one right here, this method. What's the edge case for this one? If number 2 is 0, that might be an edge case, right? Do we handle that? We don't, right? It's going to throw some sort of error when we try to do this if num2 is equal to 0. But if I knew that was an edge case and I said if num is equal to, or let's say it's not equal to, sorry, so this notation means not equal to. Whenever you put an exclamation point before it says not equal to, as long as it's not equal to 0, then you can return this. Else, return 0. Okay? Because I knew that was the edge case, now I've handled it, right? Now if I give it 0, it's just going to return 0. Right? This is no longer going to throw a bug or throw an error or exception when I provide the number 0 for number 2. Okay? That's why it's important to know what the edge cases are. Okay? Are there any other edge cases you guys can think of for this scenario? Not really, right? What if I divide by a negative number? Is that going to change anything? Not really, right? Okay, so let's go back here. Let's talk about the significance of testing, okay? My first internship was completely testing, okay? Testing is such a significant part of the software development, and when I emphasize that, I really mean it, okay? Testing is a very, very big percentage of software development. You can't really release your product unless you've done extensive testing, okay? Automated testing makes testing so much easier. Okay, now the core concept of automated testing is one test. Okay, this is kind of cheesy, but it's one test to test them all, right? So automated testing is basically what I did my first internship, and what it was is I created a collection of scripts, okay, that tested certain features of a website, okay? So I wrote the script one time, okay, and every time I ran that script, it would go ahead and test a section of the website or whatever, right? But automated testing, the importance of automated testing is that after I wrote that script one time, I no longer have to spend time to try to test that function. I can just run that script, right? And it'll test it for me. That's what we call automated testing. So what I did was I wrote a script that would test the functionality of the sign up button or something like that, right? So what it would do is it would fill in the sign up form, and it would automatically press the button sign up. Okay. Now, if I didn't have that script, I'd have to manually, every time I wanted to test that functionality, I'd have to click myself into the username, type in my username, click in the password, type in my password, click sign up. That would take what, maybe 15 seconds. If I were to run the script, it would take 1 second, right? I just have to run the script. Now imagine if I wrote 1,000 of those scripts for different functionalities of the system. Now, instead of me having to do 1,000 functionalities every single time I want to test these features, I can just go click on my entire suite of scripts, and it would one by one run every script in that folder, right? It would take maybe 20 seconds. Okay, that's the power of automated testing. Okay, so every time there's obviously a bunch of different types of tests. Okay, there's things called stress tests. Okay, which is basically you write a script that logs into the system maybe 1,000 times within the course of 20 seconds and see how the system responds under that much stress, right? This is stress test, okay? There's something called regression testing, okay? Regression testing is testing after you've updated your system to a newer version. You need to test that it still covers, or it's still, all the old functionalities still work on that system, right? That's regression testing, okay? So there's different types of testing, and honestly, there's entire teams devoted to testing. They're called QA, quality assurance, right? So if you ever see a QA intern position, you're going to be doing testing, okay? Honestly, not a bad first internship, because testing is very, very important, okay? Even in my second internship, I used the debugger. Maybe I was on the debugger maybe 30% of the time I was always coding. So I've done a lot of testing. Okay. Exactly. It's basically writing a tester class, right? But I'm gonna show you how to write JUnit tests, which are a little bit more geared towards unit testing. Okay. Okay. So a test suite is basically a collection of tests, right? And then you can run an entire test suite, right? And what that means is that you'll run every single test within that suite. And when it's done, and if every test passes, then you know that that test suite has passed and that all the functionalities that you're testing are good to go. Okay? So yeah, quality assurance. Okay? Okay, what is a unit test? Tests one unit of a program. So what's a unit of a program, like a class? What's one unit that we might test? One method. A method is a unit of a class, right? So we might have one unit test to test just one method. Okay? If you have a class with 10 methods, you might have 10 unit tests, one for each method, right? And if you run those 10 unit tests and they all pass, that means that you know that every single method within that class is correct, right? And that you can rely on the fact that when you create an instance of that class and call a method on that class, that it won't give you a bug or whatever, right? Does that make sense? So JUnit is one of those libraries you have to import to use. Okay, it's a library that provides you with all the tools necessary to create unit tests. Okay, you guys good? Okay, let's create our first unit test. Okay, so what you do is basically this. Okay, the basic idea is, you know how we use the @override tag to allow the compiler to know that we're trying to override a method? We're going to use the same @tag, but write test above it. And we're going to write that above one of our methods in the tester class to tell the compiler that that's a unit test. Okay, and I'm going to show you what that means in a little bit. So it's just like a collection of main methods, okay, basically. And creates the objects and then calls the desired method on them, and then use assertions inside the test. Okay, before we move on, can anyone tell me what an assertion is? I assert that this is true, right? That's what an assertion is, right? You are claiming that something is true or claiming that something is false, right? Okay, so in testing, we do something called assertions, okay? So let's say I set the value of this variable called my variable to 10, okay? and I assert that my value of my variable is 10, okay, that's going to return true, okay? So what we do is this. We use assertions as kind of a checkpoint, okay, to make sure that we are getting the expected value at a certain point in the test. Okay, so after maybe like you call a method, right? You might do an assertion that says something along the lines of, okay, well, after this method, the value of this variable I assert should be this value, okay? And if that assertion, what we call passes, then that means that method performed how you expected it to perform, and your test will be all good to go. But in that assertion, if, for example, you expected the value of 5, but after the method it spit out a value of 4, your assertion is going to say, I assert that my variable is equal to 5, but it gives you 4. It's going to give you an error at that point and say, hey, your method didn't return the expected output. So that would tell you that, hey, your method's messed up or something's wrong with your method, okay? So let's practice and create our first JUnit test. Okay, so what we're going to do is, since we have this, let's go ahead and go to this control practice, okay? So we have a tester class here. We have a main method, okay? And right now what we're doing is we're creating this object and we're just running all these different functions on it. So this is essentially kind of what we're going to be doing, but I'll show you how to do this, okay? So I'm going to delete this main method. All right, let's comment it out, okay? And what I'm going to do here is I'm going to write the word at test, okay? I'm going to write public void, and I'm going to put the name of the test, okay? Notice this is not a main method. I'm going to write the name of the test or method here that tells me what this method is going to test. So I'm going to say something like test calculate cost. Okay. Okay. Notice this is going to give me a error here, and it says test cannot be resolved to type, and that's because we have not imported the JUnit library. So it gives you an option here to say add JUnit for library to the build path. I'm going to click on that. And all of a sudden, it says up here that we have imported the JUnit package necessary to use JUnit testing. Okay, this is the package name. This is the class name, right? Okay. So now, what I'm going to do inside here is this is essentially a main method. Okay, you can think of this as a main method. Okay, but it gives you a name that tells you what exactly you are testing, okay? So what do you expect that I'm going to do here? I am going to first, again, just, okay, create the control flow practice object, and I am going to call that on it, okay? Now if I run this function here, or this test right here, it gives me this nice green bar at the top left corner. And that tells me that everything has passed correctly, okay? Or there's no errors within this program, okay? There's no exceptions thrown or anything, okay? Now we're gonna go ahead and type in assert true, okay? Okay. Hold on, let me take a look. Okay, so we're gonna use this assert true method, okay? And you have to pass in some sort of Boolean here, okay? So what I'm going to say is that instead of printing this, I'm going to go ahead and copy this, okay? I'm going to delete this. And I'm going to assert that the value that this prints out, calculate cost, okay? Because right now, what does it do? It returns a double, right? I'm going to assert that the value that it prints out or returns is 100.0, right? Let's see here. So this is part of a package that we haven't imported yet. So if I click this, it's going to say add static import JUnit asserts. Okay. So the difference between this one and this one is that this one only imports the assert true class, And this one has junit.assert.star, which means everything within that assert class, right? So let's go ahead and click the star one. And now we should have that functionality. Yeah, so now if you look, we have junit_assert.all. It was the top one, yeah. You need to see that again? Okay, so say I don't have that. It's going to give me this error. I click on the error message, and I go ahead and click this one right here. That's going to import the assert package, right? So everything that I need to use to call these assert functions. Okay. It's still going to give me an error here, and let's see what the error is. Okay, so it says, is not applicable for the type arguments double. String boolean. Okay, so let's look at. Okay, so it looks like it needs to print out a string and a boolean here. So let me pause the video. Okay, so the change that we had to do is we had to change the assert true, the inside to the boolean, right? So this is essentially what we don't exactly know. This is what we're testing, right? And we're assuming that it's going to equal 100. Okay, we're asserting that, right? We're asserting that this value of this is going to equal 100. Now, if it is 100, then this is going to let you pass. Okay, it's going to give you the green bar. Everything's all good. Okay, so we're good. If I say that I'm expecting a 90, it's going to give you an error. This is called an assertion error. Okay, meaning, hey, your assertion didn't pass. Okay, so we should put in the correct value here for what we expect. Okay, and if our assertion passes, then that means that our method has printed out the expected value that we were expecting, which means that our method is correct. Okay, so what I'm going to do is I'm going to create a bunch of these, and each one of these is going to correspond to one unit test. Yeah. Did it not work for you?
Yeah, it says import data import data now be resolved.
Okay, I'm going to pause the video real quick. Okay, so if you're having trouble importing the assert class right here, what you can do is you can go into your workspace and go into your project. And what you can do is you can go into build path and configure build path. Okay, and the build path is basically the path for which your project looks into for all of its libraries. So if the library is not part of your build path, then you don't have access to it. So in order to add something to your build path, you go to libraries, and you can go ahead and click add library, click JUnit, JUnit4, click finish, and it'll add this J4 unit or JUnit4 library to your build path, which means it'll be accessible by your project. Okay, then you can go ahead and try typing this command here, and it'll import the this package from this library here. Okay. Okay, so what we did is we copied the first test, and we pretty much pasted it 1, 2, 3, 4, 5 times, so that we have 5 different tests. Notice I numbered them 1, 2, 3, 4, 5. Okay, does that make sense? And what I did was I said I'm changing these values to test this, and then providing the expected output here. So if it's 50, then I should expect a value of 50, so it should return 100. Okay. When it is 0, I should expect a value of 10. So we need to change this to 10. Okay. When it's 25, I should expect a value of 50. Okay. And when it's 200, I should expect a value of what? Well, mine only goes from 50 to 100, and everything else above that is 0. So this should be 0. Okay. Go ahead and run that. We'll see that everything matches up, and all our assertions were correct, meaning that this right here on the left side, it did in fact equal the one on the right side. Okay. So that's how we tested the calculate cost function, right? Does that make sense?
So when using problems, I built a path for the
Okay, so we have just successfully created our first unit tests Okay. So, here's another thing you can do with unit tests. Okay, is that you can have more tags than just at test here. Okay. So what I can do is I can actually have a tag that says at before. Okay. Can I? Yep, I can. Okay, so I guess I have to import that before because what I can do is I can just do this. I can change this unit test. Instead of just importing this one class, I'm just going to import everything inside that JUnit class or that package. So I can just use everything inside. Okay, so now my before tag will be okay too. All right. So now what I'm going to do is I'm going to create a void method called setup. Okay. And what this before tag is going to do is it's basically going to do this. Is every time I'm going to run a test, this before method's going to run. So the way that this is going to execute is it's going to look like this. First, it's going to be this before. It's going to execute this, and then it's going to execute this test. Okay, and then it's going to run this before, and then execute the next test. So this is useful when you are repeating the same thing over and over again. So for something like this, notice that in every single test, we have to create a new object. So I'm going to abstract that out and pull this into the setup and delete that from every single one of these. Okay. Okay. Oh, okay. So it says object is not. Let me stop here, right here, and let me look at the example real quick. So we found the solution, okay? And so basically what we did was we declared the object outside, so we increased the scope from just this setup method to the entire class, so that these guys down here, these methods could access this variable, okay? So again, that's an issue of scope, right? So basically what is going to happen is it's going to run this, right? It creates a new object, and then it runs this, okay, using that new object. And then before it runs the second test, it goes ahead and runs this one again, and it creates a new object and replaces the old object with this, okay? And then it runs the second method with that new object, okay? And then it goes back and does this again, creates a new object, okay, new control flow practice object, and then runs the third test, okay? So that's the power of JUnit testing, okay? And then I think there's other tags like after also, okay? Or maybe that's not a tag. But there's different ways you can modify your tests. And so JUnit tests are very useful in the sense that once you create a test, you don't have to write it again, right? Because it should be able to test or be reused in the future, right? So that's basically JUnit testing in a nutshell, okay? So we use asserts, okay? And we use the setup method, and then you can just name your tests accordingly to what they're testing, okay? Instead of shoving this all in one main method like this, we can separate them into individual unit tests, okay? And the benefit of doing this is that, for example, let's say only this one failed, okay? Then we know that we're not handling this condition correctly, just this 50, right? Does that make sense? It's a lot easier to find out where it's going wrong than if you just did something like that. Okay? Does that make sense? Same thing with the roll dice. We could do the same thing with the roll dice. We could split that up into different tests here. We'll have a bunch of different tests. And then all we have to do is click run this JUnit test. And when everything turns green, and that means that we know that we have got the correct output for the method, right? Okay. Let's continue with this lecture. I think we're almost done here. Okay. Assertions, again, used for testing purposes. I assert this to be true. Different types of assert true, assert false. Okay. So assert false would be the exact same thing, except we assert that two things would be false, right? So we could say like this is equal to 1.0, and we can say assert false, right? And that should also return true because this Boolean is a false. This is a false statement, right? Okay, so this would essentially pass still, right? Let's change that back. Okay? So you can use either one, assert true, assert false, and there's other ones as well. Okay? It takes two parameters, the value you are testing and the expected value. If the assertion is okay, then nothing happens. If the assertion is wrong, then it throws an error, right? If your task passes the assertions, you are good to go. Okay? So we just added assertions to the JUnit test.